Electronics and Communication Engineering, Digital Electronics and Communication, and Bachelor of Engineering in Electronics and Communication. Currently, he is an assistant professor at Indian Institute of Information Technology, Dharwad. His area of research includes D2D communication, edge computing, and next generation networks. He is the recipient of International Graduate Scholarship, Taiwan, and was nominated for prestigious Commonwealth Scholarship by MHRD India in 2012. He was an external researcher at Zayed University, United Arab Emirates. In the past, he was conferred with the Best Paper Award at the International Conference VSpice 2019 and WASN 2018. He is actively involved with IEEE and ACM. Earlier, he was the MDC of IEEE Mangalore subsection and now branch counselor of IIIT Dharwad student branch, Exicom member of YP Bangalore section. In addition, currently, he is the treasurer of ACM SIG Mobile India. Today, Sir will be presenting on the new dawn of future internet, 6G and its enablers. Welcome you, sir. Kindly take over the session.
Yeah, thank you very much, ma'am, for the introduction. And let me start sharing my screen. And please tell me if everything looks fine. I mean, if the screen is visible and...
Yes, sir, it's visible.
Yeah, thank you very much. So, just a second, let me... Okay. So, thanks very much once again for the introduction and inviting me to this event. It's my pleasure to deliver this keynote talk and share whatever things I have in my presentation. So I have around 38 slides, and within 40 minutes, I guess we should be finishing this talk. And at the end, if you have any questions, I'll be happy to answer those questions. So in this presentation, I'll be mainly talking about the challenges of future networks or future internet. That's mainly because of the requirements of the future internet, as well as the use cases that we could develop or we would be anticipating in the future. When I say future, I'm referring to 2030 and beyond, and how these challenges could be addressed with the help of 6G. 6G is the enabler for addressing the future challenges. So how 6G could be the savior for addressing the challenges of future networks, as well as what factors that enable 6G, all those points I will be talking in this presentation. So let us begin the first talk here, first slide here. So let me also open my pointer to highlight the key points. So this is the graph that indicates the various generations of the cellular network. For example, we had 1G, 2G, and so on. Currently, we are in 2020, and we are witnessing 5G. So these technologies or different generations had many things in, I mean, there are different factors in these technologies. For example, somewhere analog, digital, etc. There are different key components that supported these different generations, but yet there are some common factors. I would like to highlight those. For example, if we consider 1G and 2G, they both gave us the ability to transmit data wirelessly. And if we consider 3G and 4G, that helped us in transmitting the data. I mean, data communication was possible. Maybe it could be images or video, etc. When we consider 5G, 5G consists of three key features. For example, it allows us to connect a large number of devices, massive number of devices, or it also offers ultra reliability and low latency services. At the same time, it allows the high data rate, maybe 20 Gbps or 10 Gbps in downlink and uplink respectively. In addition, 5G, we anticipated something more from 5G. That is, 5G should also support us the tactile effect. That means the network should support the transmission of touch or the sense or feel. That should be possible. But it looks like 5G will fall short, because the expectations what we have or the requirements that we have when we talk about tactile internet, 5G may not be able to reach those. So we are anticipating that to be fulfilled by 6G. So 6G is targeting 2030 into the market. So of course, 6G will deliver us maybe terabits per second, it will operate in terahertz, or it will also use the edge computing, edge with the intelligent edge, which is also the distributed edge. All these features, there are many more features that I'll be talking later. But in addition to that, the key point the 6G support us is the tactile internet that helps us to transmit the sense or touch through the internet. So 5G and 6G, the commonality between 5G and 6G is they both provide us the tactile internet, even though 5G initiates that, but 6G will fulfill those demands or the desires of the society. So these are some of the common points which helps me to categorize these different cellular networks. Now, in a pictorial form, I would like to represent it as 1G and 2G, of course, helped us in transmitting the information wirelessly. But when we see 3G, that gave us some data support. For example, you can see here some image and also some water body here. And when we consider 4G, it gave us more clarity on the content that we transmitted. For example, that could be some video. You can see here the video, this picture in more detail here than the 3G version. When we consider 5G, that gave us a kind of virtual reality or augmented reality. There's some real world setting, maybe water. Some person is trying to visualize that. That is the idea of 5G. But yet 5G did not deliver us the immersive effect. But 6G, if you see here, 6G should bring us the tactile effect or an immersive experience. For example, actually, if you see this picture here of 3G, there is some water sport going on. Similarly, in 4G, the same thing. How it's expressed in 6G is like you actually feel the kind of atmosphere you're watching or you're experiencing virtually. This is the idea of 6G. Okay, now we'll go in a systematic way. First one is the requirement of future networks. So first point or first expectation from the future network is that should be end-to-end connectivity. That means the point where the data is generated, maybe in a sensor or in any device, maybe mobile device, the data is generated at that point, and the point where the data is required, maybe you're storing that data in a cloud or in edge facility, etc. So from the point where the data is generated to the point where the data is required or the processed, we need to have the connectivity with the equal quality of service or the required quality of service. That's the idea of end-to-end connectivity. Similarly, the future network should be interoperable. That means in the future, we may have heterogeneous networks. For example, some networks may be small, some may be big, or some private networks, public networks. All this, the network element should be interoperable between these different scenarios. At the same time, it must be compatible in the sense maybe the versions we have right now should be backward compatible, or it should work with most of the other previous generations while being current. And then the dedicated timely services. I would like to bring out some scenarios here. Maybe in the future, we will have Industry 4.0 or autonomous driving or robotic surgery. These applications, they require a very precise responses. We cannot tolerate a delay of communication. So time plays a critical role in all those scenarios. So in the future, we will be having these scenarios such as autonomous driving or robotic surgery and so on, where the time is the critical factor. The next requirement of the future network is edge computing capability. So here, the main intention to use edge computing, as you all know, that to reduce the delay in data processing or getting the response. But in the future, we may have this kind of edge computing processing or facilities with intelligence. That means a kind of we will be having an intelligent network, and the intelligence is spread across. That means it's a distributed intelligence system. A network, entire entities in the network will be having the intelligence. It may span from the device itself. For example, when you consider a mobile phone, that phone itself has some intelligence, and from the phone, the data goes to the next level, maybe an edge computing level or the base station. There you have kind of intelligence. Then the data goes to maybe to the cloud or some storage facility. Also there you have the intelligence. So intelligence rules the future network. And the next requirement is ultra smart devices. Please note that this concept of mobile phones, what we have in case of 4G or 5G, that will diminish in the future. So when we target maybe 2030, when we will be looking forward towards 6G, there won't be a kind of mobile devices. Instead, we may have some smart services where you just go and log in and do your work. You get connected. And these services, at the same time, when they are smart, at the same time, they also offer us some kind of holographic experience or immersive experiences they offer us. So this is the one of the requirement of the future networks. That is, the devices should be ultra smart. I mean, yeah. In this slide, I have summarized all the previous points. That is, intelligence plays the key role in the future networks. To summarize that, if you see the lowest level here, we have some sensors, maybe in a smart city or in a smart agriculture or in a smart traffic, etc. There may be different vehicles or sensors that gathers the data. The data goes where? To the next level, as shown here, maybe to a base station or an access point, or maybe a floating base station, UAV, etc. And from there, the data goes to the next level, such as maybe a data center or an edge computing facility or a fog computing, or finally to the cloud anywhere based on the architecture that we deploy. And finally, it reaches the appropriate application. For example, if you are monitoring the smart city, these sensors will give the data into the smart city application, or it may be related to the smart transportation. Then the data comes from these sensors here and so on. So everywhere there is intelligence. For example, if you consider these sensors at the very bottom layer here, maybe we need to apply intelligence to decide which is the best channel to choose when there are many sensors operating. Or at the next level here, maybe when the data goes to the edge computing level or the cloud computing level, we need to have some intelligent algorithms to decide how to do the resource management, because there will be many devices and we have limited resources, and how to do that task scheduling, all that. Finally, at the application level also, there is the need to have the intelligence to decide how to improve the performance, or who is the next one to provide us the service, how to improve the quality of service, etc. So the summary here is, in the future network, the AI exists. Even in 5G, we have AI, but AI is mainly concentrated in the cloud. But in the future, the AI is distributed. That is, it exists at a network entity. In addition, the future networks also have requirements such as self-free networking. This figure shows that, for instance, you can imagine a city where there are many mobile users. So these mobile users by default are connected to some base stations. And these base stations in turn are connected to some central computing facilities or CPUs that are shown here. So when the mobile user moves from one base station to the service coverage area of another base station, they keep moving, and there is no boundary, or there is no need of handover when they move from one base station to another base station, because all these base stations are internally connected by the intelligent CPUs. So we can have this self-free networking, and that is a requirement of future networks, because we will be having heterogeneous devices, some mobile phones, some sensors, some UAVs, some maybe smart driving cars, etc. They are all heterogeneous. We cannot have a base station to support an UAV or separately to user, I mean, mobile phones, etc. No, that's not a good idea. So we need to have the self-free networking. That's one of the requirements. And also support diverse media. That means in addition to what we have right now, text, image, we can transmit voice or video. That's all fine. Currently, we are trying to transmit even the virtual reality, augmented reality, those data. In addition, we also need to have the ability to transmit holograms, maybe three-dimensional holograms from one place to another place through wireless transmissions. So that's also the requirement. You can imagine that that requires tremendous amount of data. I have more details in the upcoming slide. Okay, the next feature is the multi-level architecture. That means the future networks we may have, as highlighted here, the sensors and the edge computing, fog computing, cloud computing, and some of these arrangements of the network may be centralized and some of them may be distributed. So yeah, that's a multi-level architecture. So these are the requirements. So this requirement, along with that, we also have some use cases. I have listed them as internet applications in 2030. What kind of applications or use cases would emerge in 2030? I have listed only 2 or 3 to make the presentation simple. For example, the first one here, it's self-driving car. So as shown in this figure here, there is a self-driving car. When it is being driven on the road by itself, it has to communicate with several roadside entities to balance itself, to manage its driving. At the same time, there may be a flying drone. So let us assume that this car has some medical facilities that has to be transferred to the drone, and the drone will take those medical facilities somewhere else. So in this context, the car has to chase the drone at a very high speed while balancing itself on the road, keeping safe distances from other vehicles. At the same time, it has to continuously communicate with the UAV. So in this context, we can imagine that there exist multiple or heterogeneous communication interfaces with these vehicles. And also that requires to have high data rates because they travel at very high speed. So to manage the data communication, we need to have high data rate. Data rate should be supported in the network. Another use case is remote robotic surgery, as shown in this figure here. So there is a doctor who is located somewhere else, maybe in a city, and there is a patient here located in the hospital, and the doctor operates on this patient with the help of some robots. And when he presses one button, the arm of the robot will take its function, and then when he releases that button, the other arm will operate on the patient. So here the idea is a remote controlling of gadgets or some robots, which requires very high level of precision. And also, since this is a wireless kind of data transfer, we need to have very high data rates also, and at the same time, reliability. Altogether, the latency should be very, very small. If you would like to hear this, there is a minimum requirement as well as maximum requirement for latency. The meaning here is we all know what's a minimum latency requirement. That means there is some deadline. Before the deadline, the response has to come. Yeah, that's the very normal thing. But there's also a maximum latency requirement. That is, the response should come only after this much time. You can release the second arm only after the third arm becomes operational or something like that. Otherwise, there will be catastrophes. So these latencies are of the order 0.1 or 0.2 milliseconds. This is a very small number, which is very hard to achieve at the moment. Okay, the third internet application in the future would be remote holographic transmission. For example, as shown here, there is one person located in somewhere, and he would like to transfer his 3-dimensional hologram to a different location where there are audience watching that particular program. So they are separated by distances. At the same time, to transmit this kind of hologram of a person, for example, if a person is 6 feet high, then the study says that we require a data rate of around 4 terabits per second. It's a very big value. So the future networks should support that. So by considering this, the summary here is the future networks are highly autonomous and intelligent, and their requirement varies. The data rate requirements may be of 1 terabits per second or more. And similarly, the reliability of data transfer varies from 99.5 nines here up to 9 nines. So there is very, very, very low chance of losing the data. We cannot afford to lose the data. At the same time, the latency varies from 0.1 millisecond, 0.2 milliseconds, and I've thought that order. So definitely from these figures, we can conclude that the current or the existing networking technologies, maybe 5G right now, cannot support all these requirements or any of these requirements. So the storyline here is we need something better, bigger, or faster, or much more than that. So even though 5G is a smart network where we can connect many IoTs or autonomous cars, etc., yeah, it's fine. It's a smart network, but we need to have a transition from this smart network towards an intelligent network in the next 10 years, because the future internet applications will be of that order, or their requirements are so harsh or so precise, as I mentioned in my previous slide. Or to summarize, I have drawn this figure. So 5G revolves around these three key features I mentioned already. But 6G, when you see, it is AI driven. At the same time, we will be having at least these parameters, or we may have still more than that. For example, ultra high energy efficiency, ultra high density, high security, low latency, high user experience. Yeah, other than that, similar to 5G, whatever features, low latency, security, etc. Localization, yeah, these features. And these features are not offered individually, but as a combination. You can see these circles are intersecting. That means these features are offered as a combination. So that is the biggest challenge in the future. So why do we need 6G? I have 2 points here. Why do we need 6G? For example, from the previous discussion, you might have got the idea that when we go towards the next generation of internet, that is maybe when we have applications like Industry 5.0, Society 5.0, transport, etc. Of course, the requirements burdens 5G. So in 2030, normally, as normal, we will be anticipating the next generation of the cellular network, that is 6G. In 2030, we would be also witnessing this kind of applications like telepresence, holographic transmission, extended reality, etc. So all of them have a very high requirements in terms of data rate, latency, and other factors, what I mentioned, reliability and security, localization, etc. So to meet them, we need to have the next generation of telecom network, that is 6G. In addition, in 2030, when we are targeting to launch 6G, there is another event, that is United Nations Sustainable Development Goals. So there are 17 such goals, and these are the fundamental qualities every individual, human being should possess. This is what UN's vision. So that is also targeting 2030. So 6G as a technology component must support the reaching the target of UN SDGs. There is the other point, that is maybe the data rate, latency requirements, or the sense of feel, tactileness, and maybe the localization and other parameters as listed in this slide also should be met with the help of 6G. So this is the vision of 6G based on my study. So if we see here, I have listed from one of the references the KPIs, that is key performance indicators of 5G, which you can compare with 6G. So there are some points mentioned here. Yeah, some numbers like 1 terabits per second, that is the data rate, or maybe the energy efficiency and other factors. So these are just the numbers, but they have some special meaning. I will go to those in the next slide. So since the 6G, the requirements or what 6G is offering are as listed here, we can develop several use cases from 6G. For example, which may be ultra smart city, or maybe something like tactile internet, holographic communication, and many more, telemedicine and other things as shown in this slide. I will go through some of these points in the upcoming slides. So if we consider one of the use cases that we could develop with the help of 6G is ultra smart cities. So in an ultra smart city, maybe in the year 2030 or beyond, we would be having something like self-driving cars or flying cars, etc., which requires to communicate frequently with the roadside entities or other peers which will be, I mean, in that context, they need to have very high data rate and very high precision. Localization should be very accurate, otherwise there will be some accidents and many other things. So to address these, since the 6G can support us terabits per data second data rate or very high latency, I mean very high reliability or very low latency, we can build these use cases in the ultra smart cities. The second one is multidimensional reality. So as shown in this figure, in the future, we may be having not only just augmented reality or virtual reality, what we have now, we may have mixed reality. So in case of mixed reality, it could be the case that sometimes we communicate with the virtual world in reality, or we communicate with the real world in virtually. So it's a mixture of these two, where in case of augmented reality it is one way, in virtual reality is in other way, but in case of mixed reality both are combined. Sometimes we have this, sometimes we have that, and also we may have some online games such as or which uses this kind of mixed reality kind of media, or we may have some videos which consists of this multidimensional video, which requires this mixed reality kind of data representations, etc. So this kind of information or video or anything, maybe mixed reality data, that will feed all our five senses. It is not just a video or audio, it engages all our five senses, maybe in the form of a form of touch or smell, sensing, all of the senses. So that requires, of course, extended very high bandwidth and reliability. Of course, 6G should offer all that. So with the help of 6G, we can develop these applications. The third one, and very important one, or very different one from the previous generations, is the haptic communication or the tactile internet. So in case of haptic communication, actually we are transmitting the touch. You can imagine that there is an injured patient and that patient cannot express his feelings, his pain. So with the help of a special headband, his emotions can be reconstructed in the form of a video, three-dimensional video, which the doctor can use to understand the patient's pain, because he cannot express it orally in that, but he can imagine that. So his imaginations are rebuilt in the form of three-dimensional video, which helps to analyze his pain. So basically we are transmitting a kind of touch in this case. Or if we consider the tactile internet, I have another figure here. So you may look at this figure. So tactile internet is also called as IOS, Internet of Skills. So here you see here there is one person who is an expert in some activity, maybe driving or playing the guitar, etc. So there are other people who are remotely connected to this person over internet. So they also have some special devices. So when this person moves his device, I mean maybe it's a guitar or maybe a lever here, when this is moved, the people here who are trainees, they also feel the similar touch. I mean, it is not just transmitting video, it is transmitting the touch or the push or the feel, what actually happens at the other end. So in case of tactile internet, we will be transferring actually the touch or maybe taste, etc. So this is mainly useful for transferring of skills over the internet. That is what we right now do not have. Another example I would like to give here is maybe you have watched some videos, advertisements of food, maybe a pizza advertisement being telecasted in the TV, where we can watch just a video. But in the future, it should be possible that we should be able to experience the smell, aroma, or the taste, or the texture of the food when it is being telecasted from a remote station. So that is the idea of tactile internet. So definitely we need to have special sensors and actuators to experience this kind of immersive experience, so that we can engage all of our senses. That is the idea of tactile internet that we see in the future. Next one, fine one, is the holographic communication. So in case of holographic communication, as I mentioned earlier, the target here is to transmit the three-dimensional hologram of a person or an object to a remote place. So of course, we require some specifications like 6K, 16K resolution for this hologram, 240 hertz of scanning rate, and 360-degree of video coverage. So of course, these requires at least a data rate of 4 or more than 4 terabits per second, because we need to have perfect synchronization from the place where the person is speaking to the place where his hologram is actually transmitted and to and fro. Otherwise, it's not so real time. So we are targeting the real time hologram transmission or communication. Yeah, these are the use cases that are possible because of 6G, because 6G can offer us several enhanced features. With the help of that, we can build these kind of use cases. Now, the final question is how or what factors that enable 6G? I have listed here around 8 factors, but I will talk about only few of them in this presentation. So if we consider maybe artificial intelligence, quantum communication, digital twins, and all these factors what I've listed here. So basically, in case of 6G, we will be combining the physical world as well as the biological world in a digital format, so that we can do many wonders when we have the data in a digital format. So first enabler of 6G is AI. So why do we need AI for 6G? Because in the future, we will be having heterogeneous network. We will be having a variety of sensors and variety of processing devices, maybe edge devices, clouds, or there may be several numericals that such as different frequencies or maybe various verticals, kind of a smart city vertical, smart healthcare, or self-driving cars, etc. So they also require different quality of service. So if we want to satisfy all these parameters in a single network, it is not easy with the help of mathematical equations. So definitely we need to have some intelligent algorithms that help us in building this. So that's the reason we need to have AI in 6G. For example, here, until 4G, we thought of connecting the devices to the internet. In 5G, we may try to make it intelligent. We run some intelligent algorithms in the cloud, and in the future, we will be having AI at every place. So I have categorized them as 3, where AI fits in 6G. AI at the network edge, at the edge of the network. Edge of the network refers to the point very near to the sensor. Second one is AI-enabled radio, that is at the sensor itself or at the user equipment itself, because they need to decide which is the best channel to choose or which is the best time to transmit, etc. And then we also have distributed AI, that is AI is distributed throughout the network. Everywhere in the network. And next one is AI architecture for 6G. This is what we have envisioned. For example, if you see here on the outermost layer here, we have different sensors or devices, users. They are connected by some means, and they all want to send the data to the next level. The next level could be a fog computing facility or a base station, access point, or some edge computing facilities. Everywhere we have AI. And next, from there, the data goes either to a centralized facility, maybe a cloud-based RAN or broadband unit, or maybe distributed units. Both are possible. Finally, the data goes to the appropriate application. So everywhere we need to have the intelligence. This is the idea of AI for 6G. At the same time, 6G is a 3-dimensional network. That is the key feature when we compare with the previous generations of cellular networks. That is, on the terrestrial side here, we have connectivity between the sensors or mobile devices or maybe some cars, etc., or robots. And if you consider the space, we have communication between these UAVs or some aeroplanes or with the satellite. And if we consider underwater, maybe some underwater vehicles or maybe some ships, they are all connected in any way. So this is the idea of three-dimensional connectivity. This degree of freedom will enable more use cases in the future. The next enabler is terahertz communication. So as I mentioned in my very first slide, that 6G is expected to offer terabits per second of data rate. So the 6G to offer a data rate will use multiple numerology or frequency bands. For example, it will operate in the microwave bands or infrared bands or visible light bands. So the frequencies are shown here in this figure. Yeah, but generally we call the frequency ranges varying from 300 gigahertz to up to 10 gigahertz as the terahertz band. So there we have more potential to get higher bandwidth, which is required to offer a higher data rate. So the experimental studies right now have used band, for example, 95 gigahertz or 3 terahertz, where we get a bandwidth of about 21.2 gigahertz. So such a spectrum, huge spectrum is available. With the help of that, we can offer definitely better data rates. And next, the other experimental study, which is in this frequency band, has given us nearly 60 gigahertz of unoccupied frequency, the bandwidth for communication. Of course, these terahertz, when we say terahertz bandwidth or terahertz frequencies, we get higher data rate. That's okay. That is possible. At the same time, there are also certain challenges. For example, how to overcome the limitations of the atmosphere. We need to have devices to operate in these terahertz frequencies. Of course, that is all in the future, in maybe in 2026, 27, or 30. We should be targeting to develop those technologies to support these terahertz frequencies. Okay, at the same time, what opportunities we have? If you see here, we have Tera Wi-Fi. Tera Wi-Fi, in the sense, maybe in a small geographical region, we use terahertz frequencies, which can be pointed to specifically to a position to offer very high data rate, maybe augmented reality or virtual reality, such kind of activities you can do or access such kind of data. Or maybe industrial settings where we have different IoT devices, they are connected, where the requirement is very high data rate. In the future, I'm talking about, then we can go for this. At the same time, connecting the backhaul, integrated access backhaul. The backhaul can use the terahertz frequencies, or as usual, the satellites, low Earth orbit satellites can be used for this kind of communication. So there are right now several efforts all over the globe to launch LEOs, low Earth orbit satellites. For example, China has, or United States, all different countries have launched their own satellites explicitly for 6G, that is LEO satellites. Yeah, we have some benefit. At the same time, we have to address certain challenges, how to develop such devices, or how to overcome the environmental challenges when we deal with such high frequencies, all that we have to take care in the future. And next one is the blockchain for security. So blockchain is one of the candidates that offers security for the future generation of cellular networks when we talk about 6G. So in case of blockchain, it is a kind of distributed ledger that allows different parties who take part in the communication to authenticate themselves or identify themselves and authenticate the other users as well. For example, I have a scenario here. There may be different users who want to participate in a virtual meet like what we have right now. Maybe these are not actually the people, but maybe some are machines, some are people, etc. But they want to authenticate their identity. In that case, they may use blockchain to represent their identity, and other users can actually verify that. That's what actually happens in the case of blockchain. So by this, we can bring in the concept of trust or reliability, while there is a problem with the privacy. We may have to sacrifice the privacy because your data is visible to everyone. Other than that, the trust and reliability are easy to offer here in case with the help of blockchain in the future. The next one is intelligent communication services. So this is another enabling technology for 6G. So when we consider a wireless scenario, wireless communication scenario, it is possible, as shown in this figure, that we may have a direct line of sight path. For example, this base station is transmitting to the user here. There is a direct line of sight path, but there is sometimes there is no direct line of sight path. For example, we have the data transmitted here has to reach this particular user. There is no line of sight path. In that case, what do we do? The data is transmitted from this base station to a surface which is called as a reconfigurable intelligent surface or smart surface. So these are made of metamaterials. So when the data falls, I mean the signal, electromagnetic signal falls on this surface, they actually have the ability to modify the signal. That means they can change the modulation settings or can change the link budget or enhance the, I mean, amplify the signal, etc. In whatever way we require. So basically the idea here is that these surfaces, which is called as RIS in this figure, they are the smart surfaces. In the case, they are software programmable. So we can program them using software and accordingly they behave. That means we can customize our transmission setting. For example, in this scenario, there is a direct path. At the same time, there could be a reflected path as well. So it is not the case earlier. What we had is reflected path. Maybe it's not so strong, but in this case, we can have this reflecting surfaces pre-programmed. So whenever the ray is incident on this surface, it will amplify the signal or change the modulation, whatever parameter you want to set. It can be set. As a result, we enhance the quality of communication or transmission. So that is the idea of smart surfaces. So that is another enabler of 6G. And finally, the digital twins. I have 3 more slides. Okay, in case of digital twins, actually it's a digital representation of the real world or real objects in a virtual or cyberspace. I have a slide to represent this. For instance, here we have a smart car, maybe. This is a real world entity, and that has many sensors that collects and that sends the data, right? So this data from these different sensors can be collected, and we can build actually a simulated car or a function which is called as the digital twin. So this twin is actually a replica, virtual replica of this physical object. Similarly here, so in this context, so if there are any changes required in the functioning of this car, you do not have to actually open this car and do that. Instead, we can modify the parameters what we have in the software program and then sync. Then those changes should be reflected in this car. That means you do not have to touch or do not have to alter the functioning of the physical car. Similarly, in case of healthcare, the digital twins are useful in building the twin of the organ to be investigated or operated. For example, in this figure, the heart is shown, which is actually the digital representation of the patient's heart. So the doctor can study this, or he can apply his different methods of treatment on this first, and then actually he can implement on the real patient. Otherwise, there could be some catastrophe. Similarly, yeah, we have the real space here, and this is the virtual digital twin, which is built using the data from this smart device. And there is a perfect synchronization between these two. So this requires actually a tremendous amount of data rate to support, to have a digital twin in real time. Finally, how 6G is going to help in developing or enhancing the SDG, Sustainable Development Goals. 17 Sustainable Development Goals are mentioned here. For example, I'll take this one. If we can really implement a smart agriculture, where you collect the data from your field and process it at the cloud and do analyze the data, etc., we can actually enhance the quality of the crop that is grown, and also we can sell it using fintechs, financial technologies, at some better places to get a good price for the crop. So we can eradicate poverty. At the same time, since we have good food that is grown crop, no hunger, I also mentioned about healthcare, how 6G can support better healthcare by avoiding the latency and reliability of communication. Similarly, we can also target different SDGs. So the main requirement when we talk about 6G as an enabler for sustainable development goal is the networking or network availability of connectivity. So how 6G can wipe out digital divide? That is, 6G has various numericals, such as 6G can provide us mobile broadband, one connectivity, or some areas which are difficult to be connected. It can offer the low Earth orbit satellites. Through that, some communication or connections, and also we may use sometimes the UAVs or floating base stations, etc., to connect the areas which are sparsely connected. In this way, we can eradicate the digital divide. We can connect every aspect of the globe, and we can try to promote the sustainable development goals, which are the fundamental qualities every human being should possess in the future, so that we see how we can improve the quality of life of every human being on the earth. This the expectations from 6G. Yeah, this is my last slide, and thank you very much. And the main content of this presentation comes from our paper from IEEE Access, and we are very happy to say that we are the first Indian authors to publish an article, extended article on 6G in an IEEE journal. So thanks very much for your attention.
Thank you, sir. If there is any question from the participants, kindly do post it in the chat box, or you can unmute yourselves and ask.
I have a question. Yeah, some question is there. Sneha, can you read out?
Yeah, sure, ma'am. Sir, there's a question from Sangana Basava. How can we optimize the CapEx? That's what he's asking.
Okay, so right now, I mean, the financial or economic aspects of 6G, I think we are too far to address those challenges. So in this, actually, I should have mentioned that this is kind of a vision talk about 6G. Many of the algorithms or precise technologies, we are not sure at the moment, because we are still in the vision or road towards 6G. Similarly, this question also, I think we have to move further, maybe a few more years, have to wait to about addressing these economic aspects of 6G.
Thank you, sir.
Of course, I could give a pointer here that we need to have better use cases to support better CapEx. But I do not know what use cases would come up in the future so that we can have a better CapEx.
Yeah, I was about to ask the same question. Okay, thank you.
Thank you very much, sir, for such an informative session on the need of having a new set of communication technologies for the emerging internet applications. Thank you so much for joining us on this keynote session.
Yeah, thank you very much. Thank you very much.
Yeah, thank you so much.
Continuing with this session, I request Gayatri Hegde, research scholar, to introduce the next keynote speaker of the day, Dr. Sanjeev Kumar Majumdar, who will be presenting on the Indian startup in the field of information processing, NLP, AI, and ML.
Yeah, thank you, Sneha. It's my privilege to introduce Dr. Sanjeev Kumar Majumdar. Dr. Majumdar is presently with the National Research Development Corporation, Delhi, as manager, IPR and incubation. His service at NRDC include Deputy Manager IP, Scientific Officer and Consultant IPR, Intellectual Property Consultancy and Management Division. Sanjeev experience includes Associate Fellow, National Innovation Foundation, Ahmedabad, set up by Department of Science and Technology, and Research Associate, Indian Council of Medical Research, and at NISCAIR, CSIR, AIS Patent Information System. He has obtained his Doctor of Philosophy in Botany from VBS Purvanchal University, Bachelor of Science and Master of Science from Deen Dayal Upadhyay Gorakhpur University. Welcome you, sir. I would also take this opportunity to welcome Ms. Fatima Motiwala, who is a colleague of Mr. Majumdar, who is accompanying him today. And she is also a subject expert in the same technical domain. Welcome you, ma'am.
Thank you so much, ma'am. Myself, Fatima.
Yeah, welcome, ma'am. So I take this opportunity to welcome both, and over to you, sir. Sanjeev, sir.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Am I audible now?
Yeah.
Yes, sir, you're audible, sir.
And starting, Fatma, can you please share the screen from there? Thank you to organizers for calling me for this program. It's very informative program. I was listening to previous speaker, and in very detail about the 6G and AI and ML, everything has been discussed in this previous session. The topic of what we have selected.
Sir, you're muted, sir.
Shaila, ಏನು ಕೇಳಿಸ್ತಾ ಇಲ್ಲ?
Hello, sir. We are not able to hear you, sir.
I'm just trying to share my screen.
Sir, if you are not able to share, shall we share that PPT, sir?
Please, please, ma'am. The same
Yes,
PPT.
sir. ಸ್ನೇಹ PPT ಕಳಿಸಿದ್ದೀನಿ ನನ್ನ WhatsApp ನಲ್ಲಿ, ಅದನ್ನ ಒಂಚೂರು ಶೇರ್ ಮಾಡಿ.
So, I was just talking about
Yes, ma'am.
from NRDC, National Research Development Corporation, it is, and it's the Government of India enterprise. We are in business of technology transfer. We source the technology from all the research institutes, and then we commercialize those technologies and launch into those to whom we commercialize these technologies, the industry, they themselves launch the product into market. So it's we are a bridge between the research and the product. So where all research is happening, not all you academic researchers and from research institute researchers, they do their research, they make their product, their feasible product at lab scale. Then we upscale that and we try to get it launched for the use of the public. So that's our process, and into this process, a lot of things are happening there. So that we do. As today's topic is, we have to discuss about the AI, ML, and NLP business. So NRDC, we are also into the startup ecosystem where we are supporting to we are working with Ministry of Commerce and Industry to its department DPIT, and startup applications being received there are also being presented to the interministerial board for the tax exemption. Into that, those who innovative startups, those who are applying for exemption, they are getting those exemptions. from the paying the tax for like 3 years under Section 80 IAC. So that's the process where innovative startups are getting the real reward. So as starting from the beginning, slide is open now. Everyone is viewing that. So we are from the NRDC. I introduced that and the topic as suggested. Next slide, please. Hello.
Sneha, move the slide. Next slide.
Next. As we are start from the introducing. So our government has invested about 477 million in AI, IoT, big data, and all the field of IT, including cyber security, machine learning, and robotics. Actually, because of why this investment is there, we have a good technological resource with us, and advancement is very much required to sustain in market. And the Indian startup system has been seen a great deal of growth in recent years since beginning when we are in cyberspace. So as per AM research, Indian AI startup raised about 836.3 million in funding outlay in the last 7 years at a 9.7% year-on-year to go growth. So this research is also happening, how our startup ecosystem is flourishing and how we are delivering the product. So here, next slide, please. So previously it had been discussed. It's not exactly. I'm not supposed to define again, as AIML is all in our part of life. Like if you are using search, you are putting a search query in Google or our Facebook feed and Facebook special and recommendations in our shopping sites. Whatever shopping carts we are going for, all suggested items are being suggested by them. They all these apps, they use the machine learning and they suggest those products to us. So it's more than 500 million Indians are using right now, and the machine learning is part of their life. Maybe they are not knowing that, but these apps, they are suggesting those things to them based on machine learning only. So it's part of life we are using, but all in as an Indian citizen, we may not be knowing that it's part of machine learning, but it has reached all those nooks and corners in our life also. Next slide, please.
Sir, you just try it out now because control has given to you. You just check it out. If not, we'll take over that. Sanjeev, sir?
Yes.
You just try to change it, sir. We'll see. If not, we'll see because it's not happening here.
So if we go with examples, what we at RDC we work for. So I have tried to just to detail about few startups here from India. If it's been starting from the first in 2007-8, when at that time the startups, we are not knowing about the startups, we are not discussing about the startups, but some promising entrepreneurs from the IITs, those who are working into these fields. So they were looking for some investments and it was required. So at that time, our visionary chairman managing director, he thought about to invest into those smart entrepreneurs, those who are working into those challenging fields. It's thinking about a problem and then going into research and delivering a product. So like that, one company came into IIT Madras. It was even at that time they didn't name the company. Later after our investment from the NRDC, they formed the company Unifor, and Unifor is now Unicorn. And even recently they have also acquired a company, Jakarta, which is also into process of natural language processing. This Uniphone, their product, earlier they named it Amina. The Amina is basically a language processing system which communicates based on the input voice and then what the user is intended to communicate. So it's this letter name from the Amina. So it's a good product into natural language processing, and it's being marketed as a kind of alternative of Siri. So it's a very promising product from India, and globally being used. Now they have opened the office in US also.
So we are not able to hear you, sir.
So I was saying about the Uniphone. So Uniphone is disrupting an outdated customer service model and bridging the gap between the machines and focusing on the conversations, AI and ML, making possible for every voice on every call to make it truly heard by the system. So it was funded in 2007 and 0.3 million it was funded by NRTC, and we disinvested that in 2014, and they have given a good return to NRTC.
ಶೈಲಾ ಏನಾಗ್ತಿದೆಮ್ಮ? ಶೈಲಾ? ಸ್ನೇಹ?
ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದ್ರು ಅನ್ಸುತ್ತೆ. ಕನೆಕ್ಟ್ ಆಗಿದ್ರು.
ಇಲ್ಲ ಇಲ್ಲ, ಯಾರು ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾನೆ.
ಅದೇ ಸ್ಪೀಕರ್ ಮೂವಿಂಗ್ ಅಲ್ಲಿ ಇದಾರಂತೆ, ಪ್ರಾಬ್ಲಿ ಅದೇ
Oh,
ಇಶ್ಯೂ.
oh, oh. Okay.
Sorry, sorry for disturbance. Some little problem. Am I audible?
Yes, sir. Now you are audible.
If you discuss about more and we come to know about the who have delivered the good products, like previous session it was being said that AI and ML is everywhere, and a good startup is there from Bangalore based only. It is Viramai Health Analytics. They have founded their company in 2016. It is health tech startup Viramai Health Analytics. It's AI based and the radiation free breast cancer screening solution they have provided, where they have named it thermalytics, and machine intelligence is over the thermography images. The full body is being scanned. If there is some abnormal heat in the body part, it is being diagnosed by this thermal cameras and image based on image analysis. They were able to decide that the person who is under scanning is having breast cancer or not. So it's very good technology and promising technology. It's provided that, because wherever in this carcinoma cells are being developed, it causes some inflammation and heat nearby areas. So that's why they are detecting those spots and analyzing that. And a good database in background they have. So it's a very accurate screening. Other than previously, but we were using those were basically uh, radiation based, and being it is being advised always we should minimize the radiations screenings as much as we can. So it's very good in those cases. The analysis can be done by thermal analysis, and when they came to DPIT case, it has been sanctioned and acquisition by DPIT for next 3 years. So they are developing their product, they are installing their product, and whatever income they are getting, they don't have to pay income tax to the government for their innovative product. Similarly, if we discuss about any another startup, so it's Myelin Foundry. It's a deep tech product startup and transforming human experiences and industry outcomes by building artificial intelligence algorithms on video, voice, and sensor data for based customer devices. It develops AI-based algorithms on video, voice, and sensor data for edge devices. Malin Foundry has raised a total uh, $2 million funding by 5 investors, and beyond Next Ventures and India partners are the most recent investors into this company. So it's again a very good new startup, but they have secured a very good investment recently. Out of so many startups, we found that those can be discussed here. Another startup which was found in 2015 at SIGTuple combined, SIGTuple, which combines the power of microfluidic, robotics, artificial intelligence, and cloud computing to create smart diagnostic solutions which make quality healthcare delivery affordable and accessible. So their smart automated solutions, high volume diagnostic screening test improve efficiency of doctors, enable telediagnostics, and reduce the new paradigm connected to the test. So they have secured about 40 million and the promise of the using AI in diagnostics, because diagnostics itself when we go to the any diagnostic center where they give the results, but all those results are being monitored by pathologists. They are being MD, having a highest qualification into those things, or a MD in radiology or MD in pathology. They monitor all the results. But before that, to save their time and to give a good accurate results, machine learning and AI is totally supporting. Machines are being used, and they have a good database in background. So they are accurate results they are suggesting, and then being correlated by further by expert doctors. So that has helped in telemedicine system, because where the doctor is not available, but the diagnosis is being taken, sample is being taken, or diagnostic experiments are being conducted. Those results are being shared over the telemedicine system, or to the doctor available there, expert available there. So they suggest that it's okay, and the results are as per the machine what says the same thing, each opinion of that. So then after they issue the reports that it's okay.
Sir, again, it is not audible. Sir, you are not audible.
ಶೈಲಾ ಶೈಲಾನು ಇಲ್ವಮ್ಮ?
ಶೈಲಾ ಇದ್ದಾರೆ, ಮೇಡಮ್ ಅವ್ರದ್ದು ನೆಟ್ವರ್ಕ್ ಏನೋ ಇಶ್ಯೂಸ್ ಆಗ್ತಿದೆ ಅನ್ಸುತ್ತೆ. ಸರ್ವಿಸ್ ಮೂವಿಂಗ್ ಅಂತೆ.
ಸರ್ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ.
ಅಲ್ಲ, ಅವ್ರ ಕೊಲೀಗ್ ಸೇರಿದ್ರಲ್ಲಮ್ಮ, ಅವ್ರ ಕೊಲೀಗ್ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಲಮ್ಮ ಅಟ್ಲೀಸ್ಟ್, ಹಿಂಗೆ ಬ್ಲಾಂಕ್ ಬಿಡೋಕ್ಕಿಂತ.
ಅದೇ ಬೋತ್ ಆಫ್ ದೆಮ್ ಐ ಥಿಂಕ್ ದೇ ಆರ್ ಟ್ರಾವೆಲಿಂಗ್ ಟುಗೆದರ್.
ಫಾತಿಮಾ ಮೇಡಮ್, ಆರ್ ಏಬಲ್ ಟು ಹಿಯರ್? ಮೋಸ್ಟ್ಲಿ ಅವ್ರಿಗೆ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಫಾತಿಮಾ,
ಐ ಥಿಂಕ್ ಬೋತ್ ಆಫ್ ದೆಮ್ ಟ್ರಾವೆಲಿಂಗ್ ಟುಗೆದರ್.
ಅವ್ರು ಫ್ಲೈಟ್ ಇಂದ ಇಳಿದ್ರು ಅಂತ ಹೇಳಿದ್ರು. ಫ್ಲೈಟ್ ಇಂದ ಇಳಿದು ಕಾರ್ನಲ್ಲಿ ಹೋಗ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಡೆಲ್ಲಿಲಿ. ಏನಕ್ಕೆ? ಒಂದ್ ನಿಮಿಷ ಕಾಲ್ ಮಾಡ್ತೀನಿ ರೀ.
ಮೇಡಮ್ ವ್ಯಾಲಿಡಿಟಿಗೆ ಸರ್ ಬರ್ತಾರಾ? ಬರ್ತಾರೆ. ಇನ್ನ 15 ಮಿನಿಟ್ಸ್ ಇದೆ. ಹೆಂಗೆ ಹೌ ಟು ಸ್ಪೆಂಡ್ 15 ಮಿನಿಟ್ಸ್? ಫೀಡ್ಬ್ಯಾಕ್ ಇಂದ ಶುರು ಮಾಡ್ಬಿಡೋಣಮ್ಮ ಪ್ರೋಗ್ರಾಮು. ಸರ್ ಬಂದು ಜಾಯ್ನ್ ಆಗ್ಲಿ ಅಲ್ವಾ?
ಸರ್ ಇವಾಗ್ಲೇ ಶುರು ಮಾಡ್ಬಿಡೋದು ಅಂತನಾ?
ಇದೇನು ಕಂಟಿನ್ಯೂ ಆಗೋಂಗ್ ಕಾಣಲ್ಲ.
ಅದೇ ಮತ್ತೆ ಅವ್ರು ಅಷ್ಟೊಂದು ಟ್ರಾವೆಲ್ ಅಲ್ಲಿ ಇದ್ರೆ ಕಷ್ಟ ಅಲ್ವಾ? ಹೆಂಗಂದ್ರು ಫ್ಲೋ ಇಲ್ಲ ಅಂದ್ರೆ ಮತ್ತೆ ಅದು ಸರಿನೇ ಹೋಗಲ್ಲ. ಬಟ್ ಸರ್ಗೆ ಹೇಳ್ಬಿಟ್ಟೆ ಶುರು ಮಾಡೋದು ಬೆಟರ್ ಅಲ್ಲ ಮೇಡಮ್?
ಅಥವಾ ಸರ್ಗೆ ಲತಾ
ಸರಿಗೆ ಫೋನ್ ಮಾಡ್ಬಿಟ್ಟು ಈ ತರ ಇವಾಗ್ಲೇ ಶುರು ಮಾಡಿದ ಫಸ್ಟ್ ಶೈಲ ಏನ್ ಹೇಳ್ತಾಳೆ ನೋಡಿ.
ಒಂದ್ ನಿಮಿಷ ಕಾಲ್ ಮಾಡಿ ಕೇಳ್ಕೊಂಡ್ಬಿಡ್ಲಿ ಮೇಡಮ್.
ಅಲ್ಲ ಶೈಲಾ ಫೋನ್ ಮಾಡಿದಲ್ಲ ಏನಾಯ್ತಮ್ಮ?
ಕಾಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಶೈಲಾ. ಒಂದ್ ನಿಮಿಷ ಅವ್ರು ಏನ್ ಹೇಳ್ತಾರೆ ಕೇಳ್ಕೊಂಡು
ನೆಟ್ವರ್ಕ್ ಸಿಗ್ತಾ ಇಲ್ಲ ಮೇಡಮ್. ಕಾಲ್ ಮಾಡ್ದೆ, ನೆಟ್ವರ್ಕ್ ಸಿಗ್ತಾ ಇಲ್ಲ, ನಾಟ್ ರೀಚಬಲ್ ಅಂತ ಬರ್ತಾ ಇದೆ.
ನೀನು ಲತಾಕ್ ಸರ್ ಏನ್ ಮಾಡ್ತಿದಾರಮ್ಮ? ಊಟ ಮಾಡ್ತಾ ಇದಾರ?
ಅಂದ್ರು ಊಟ ಮಾಡ್ತಾ ಇದೀನಿ, 3:30 ಜಾಯ್ನ್ ಆಗ್ತೀನಿ ಅಂದ್ರು ಮ್ಯಾಮ್.
ನಾವು ಫೀಡ್ಬ್ಯಾಕ್ ಅದರಿಂದ ಶುರು ಮಾಡ್ಬಿಡ್ಬೋದಲ್ಲ ನಮ್ಮ?
ವೆಲ್ಕಮ್ ಸ್ಪೀಚ್
ಅಲ್ಲ.
ಇನ್ನೋಕೆ ಬಟ್ ಸರ್ಗೆ ಸರ್ ಈ ತರ ಮುಗೀತು ಶುರು ಮಾಡೋದಂತ ಒಂದ್ ಮಾತು ಕೇಳ್ಬಿಡಿ.
ಅಲ್ಲ ಈ ಸ್ಲೈಡ್ಸ್ ಎಲ್ಲ ಒಂದ್ಸಲ ಹೋಗಿ ಹಾಕ್ಬಿಡ್ರಪ್ಪ.
ಪಾಪ ಅವ್ರು ವಿರಾಲ್ ಶಾ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇದೀನಿ ವಿಡಿಯೋ ಕೊಡ್ತೀನಿ ಅಂದ್ರು. ಇವ್ರ ಹತ್ರನೇ ವಿಡಿಯೋ ಇಸ್ಕೊಂಡ್ರೆ ಚೆನ್ನಾಗಿರೋದು.
ಬಟ್ ಅವರು ವಿಡಿಯೋ ಕೊಡ್ಲಿಲ್ಲ ಮೇಡಮ್, ಬಂದ್ರು ಅವ್ರೆ. ವಿಡಿಯೋ ಕಳ್ಸಿರ್ಲಿಲ್ಲ ಆದ್ರೆ ಅವರು ಇವ್ರು ಸ್ವಲ್ಪ ಸ್ಲೈಡ್ಸ್ ಒಂದೊಂದ್ 2 seconds ಹಂಗ್ ಶೇರ್ ಮಾಡ್ರಪ್ಪ ಅವ್ರಿಗೆ.
ಚಾಲೆಂಜಸ್ ಏನೋ ಇದೆ ನೋಡಮ್ಮ, ಚಾಲೆಂಜಸ್ ಬೈ ರಿಸರ್ಚರ್ಸ್. ಅದೇಳಮ್ಮ ನಿಮ್ಗೆ ಬೇಕಾಗತ್ತೆ ನೋಡಿ. ಇದೆಲ್ಲ ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. ಕಂಪ್ಯೂಟಿಂಗ್ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್, ರಿಸೋರ್ಸಸ್ ಅಂಡ್
ಓದ್ಬಿಡೋದಮ್ಮ?
ನಾನೇ ಓದ್ತೀನಿ ಬಿಡಮ್ಮ ಶ್ವೇತಾ.
ಸರಿ.
So in the class I have discussed about all these problems. If you remember, PhD students, quantity and quality of students entering AI ML research in India, they are telling they are not good. Computing infrastructure very poor. Resource and administrative bottlenecks always there. You are lucky that in Bangalore University it is very less, but resources are not very high. Lack of good quality labeled data set. You know how difficult it is to get good quality data sets. You have to either start collecting yourself or build yourself, or you have to write to various authorities, and they are not very comfortable sharing the data set. That is labeled data set, very hard to get. Siloed research approach within a university. Yarar explain ಮಾಡ್ತೀರಾ, ಆನ್ಸರ್ ಮಾಡ್ತೀರಾ? What do you mean by siloed research approach within a university? ಶ್ವೇತಾ ಓದ್ತೀನಿ ಅಂದಲ್ಲ, ಇದಕ್ಕೆ ಕೇಳೋ ಆನ್ಸರು. What do you mean by siloed research approach within a university?
Ma'am, researchers do not share their work with each other, and therefore there is no much discussions and collaborations happening.
What they do is they work in small groups, and other groups won't come to know, and sometimes there will be repetition. Okay, siloed means disconnected. So disconnected groups or disconnected researchers. And you see, for example, if I ask my MTech students to select their own topics and give AAT, sometimes 2 students would have selected the same topic, and I have to reject. That means because they don't talk to each other. Okay, siloed means working in isolation. Very exact meaning is working in isolation. Then what happens? Good quality research won't come. Okay, these are all the challenges faced by researchers in India. Research collaboration and learning from other countries. Okay, these are some of the collaborations they have written, and they talked about. Okay, let me go back. He spoke about Mujumdar spoke about 2 startup or entrepreneurship ventures. One was Niramai. So we're happy to share with you all that Niramai CEO is, or CTO is from UVC. Geeta Manjunath, she is Dr. Manjula SH's classmate, and she was working for various leading organizations. Now she has left and started her own company on healthcare, that is the detection of early detection of cancer, and giving some suggestions. Okay, as he told, she uses thermal imaging technique to find out detect the cancer. Okay, he spoke about 2 ventures. One is from UVC. I'm very happy to share that. So they have listed research collaboration and learning from other countries. What other countries are doing, how much fund they are diverting or spending on research, and we hardly spend any amount on research. See, they have written China will build a USD 2.1 billion technology park for AI research in Beijing. Beijing is not a very advanced province compared to Shanghai, but they want to build it in Beijing now. Okay, Canada was the first country to release a national AI strategy. Japan, US, and France, how much they are spending on AI research that they have shared. Okay, next slide. Translating research into application, very, very difficult. Why it is difficult? Because again, we work in silos or in isolation. We do academic research. We hardly don't try to publish in good journals or conferences, and industry is isolated from us. They don't have confidence on academicians or on educational institutions, so they don't ask us to do their research. That is the major problem in India. And though we think of doing research with industry, initially we start with great enthusiasm, but we lack confidence. We say that, see, every speech I usually talk that let us have collaboration, let us work together. So at that moment I talk, but after some time, we don't have the confidence to go back to them and ask them to share their expertise and learn from them. So because of this, it is very difficult to translate research into application. That is what should happen. When you do some research, that should translate into an application which is of social concern, or it should give some solution to the social problem. But that is not happening in India. So how it is can be done, they have told healthcare, hospital productivity system, diagnosis system, financial services, risk modeling, fraud detection. All these are leading research topics. High tech and communication, better search outcomes, information security and biometrics, retail, India specific challenges, that flood modeling, Indian language processing system. You know that India has thousands of languages, and it's not that easy to process them. Monsoon prediction, though, see, they told that 20th to 24th there will be heavy rains, and we were thinking whether to do our cultural program in the quadrangle or not. But luckily it never rained. Only yesterday or today morning it rained. That means our prediction system is not strong. We predict something and something happens. Okay, and other domains. Yes.
Madam, sir, join adro matte. Sir, join. Sir, join.
Thank you, ma'am. Thank you, ma'am.
So I teach a research methodology, so I was sharing my views with my students. Kindly
thank you, ma'am.
continue,
Thank you, ma'am.
Madam, sir, madam is the organizing chair, sir. She's the syndicate member and dean of Bangalore University,
thank
sir.
You. Thank you, ma'am.
Thank you, sir. Please continue.
And I tried to dot down these points, and you detailed everything as I was delivering. It's
yes,
very exactly the same thing. What happens, what problems we face, because we say that we have a good research papers, we have a good researchers with us, and when the product delivery we think about, then it takes time, it takes investment also. So that's why I selected that key. We are in the process in this conference. It is for the information processing. So in information processing, we all do research. Our research papers are good. IEEE is flooded with our researchers. So shall I took some examples, those who have delivered the products, and what exactly the requirement is for those who accept those challenge and they bring these startups into in action. Many of them, they have gone into the merger and acquisition, and a few they are surviving. But things are very good that we have a good resource with us, and this conference is also happening with good researchers. This previous expert, he delivered many things about the 6G communication. Even we are struggling with our 4G, but hope for the best when 6G is coming. we'll have good things. Recently, I was part of a meeting discussion at ministry there. So Ministry of Commerce and Industry, they are also focusing something. This machine-to-machine communication should be there. So at present, many things are happening where this machine-to-machine communication is not there in the batch-wise, or this system is being manufactured and being monitored by the human being, or human source is being employed more and more into that. And later, quality checks are also being done. And even one step to another step process, there is no communication between the machines. So that's why government is also focusing on Industry 4.0. So where we talk about the Industry 4.0, there is all these things are required, where a communication between machine to machine should be occur, and into that this quality concerns and the checks, everything has to be completed by those all our installed cameras and logics, what the programming we are keeping into those systems. So that's why I try to push which are here into. So these are the sectors where the requirement is there, basically for our AI and ML. So first I selected as a healthcare, very much required. I was giving an example previously, right 10 minutes back, where our hospitals are having a number of beds in complete hospital management. It's required complete. Now many of the hospitals, they have been enabled themselves. Good companies, they have come into. Even I have seen personally, I experienced one hospital. They are having the prescription system completely automated. They don't have to scan and write or any the same traditional method they are using into that hospital, pen and paper. But the pen is keeping scanning the medicine name, what the doctor is saying, and what diagnostics are being referred to the patients. So there also, it's very good thing. The paper, they have made the paper as a matrix and pen as a scanner, and based on this matrix, they are scanning that, and they are changing those handwritten prescriptions and handwritten diagnoses into machine readable format, and again storing those data about the patient details, about its disease, its symptoms, its all patient data, background data, its history and its medicine prescribed, and then again when the next course of treatment, what was the symptoms, and everything which in the background, the data is being recorded and being processed by those hospitals. So in hospitals, it is very useful and being used by many of the companies. Similarly, in hospitals, not in diagnosis also, it is very much required. When we talk about the telemedicine, from one place to another place, the treatment has to be done, where the expert is not available in the remotest far village, where diagnosis machine can be installed, but with a less, not that much qualified radiologist or a technician is there, and once he diagnoses, he conducts a X-ray on a patient there, he immediately transmits those to the hub, where in the telemedicine system, the doctors are available or radiologists are available. They are examining and transferring those data. It was a very first concept in the telemedicine. Nowadays, it is exactly being uploaded and the results are being downloaded. So in the complete diagnosis, we used in this PC, our COVID testings we have completed. All those data are being documented and being analyzed and being reported by the government. So it's complete. This system is there where it is required. Similarly, in financial services also, there is a scope of those things where the risk modeling, fraud detection, and this decision making for the bankings. A lot of apps now they have come with. They keep on screening the financial behavior of a person based on their PAN number only, or based on their borrowings, and how efficiently he is managing. So here also an analysis in background analysis and a suggestive decision for the bank is required. So that's those few startups came into those sectors also. So it's happening on these high tech and communications. You all know that these are happening. Things are already retail e-commerce. In the first introduction, I said that our Amazon or our Flipkart, wherever we are screening for a product, and then they suggest these are the similar products. This product is not available. So that is also based on our machine learning. They are suggesting those things. Even the price band also, they think about which price band I am looking for and which area I am looking for. So those things are they are covering into this by machine learning products. So it's there already in process, and few challenging areas are required where we are thinking about our agriculture, as sir was saying previously, our previous speaker. In agriculture, if it comes, it will predict the rain, and it will predict the yield of the our agriculture produce. So that will be a very good thing if when it is being implemented. Even a few startups nowadays, they are working on the soil moisture and the growth pattern also they are analyzing. And one startup I came to know that was they were just confirming the variety of the product which has been produced by the farmer, and based on the confirmation, its quality and moisture content, they can go for a good negotiation with the those brokers, those who buy their products into the mandi, where the agriculture products are being sold. So that those things are also into the use now, based on this AI only. And similarly, if I say it's happening everywhere. So these
one minute, sir. Shaila, I think sir has joined. Shaila?
Hey, madam.
Sir, join agidare.
Sir, join agidare. So welcome you, sir. Majumdar sir, Venugopal sir is the Vice Chancellor of Bangalore University. Sir has joined with us, sir.
Okay. Namaskar, sir. So I'm stopping here. Thanks to organizers for calling me for this program here. And I tried, but for the travel problems, I could not in the way it could present. So I'm thanking you to all, and thanking you to VC sir also. Ma'am, please continue.
Yeah, you can continue, sir. You can continue.
So we are happy to inform you that Niramai founder is from our college. Dr. Geeta.
Great ma'am.
Geeta Majumdar, she was a first rank gold medalist from I think 87 batch or so. She worked in a number of leading companies. Now she has founded her own company and she's doing extremely well. Every now and then she gives talks, and they will have monthly meetings on the awareness of cancer. And I try to attend those sessions, and they do some yoga sessions for cancer patients. What yoga, simple yoga can be done. All those things they teach. So it's very informative actually. She is very good.
Thank you, ma'am. I'm just being part of that. When I was discussing this case in the ministry at the DPIT, that this case has to be must have been given the exemption. So I detailed everything about that startup in that meeting. So it happened very long back, and now I know they are doing good. Yes. And TV program also they have been featured as a good, promising startup from the country.
And they also devised something to find out the COVID the screening in the airports without contacting the patient. Again, thermal scanning, how to find out whether the traveler is a COVID patient or not. That also they tried. I don't know how long they went in that.
Their product, that COVID diagnosis that could not come into market, but their products have been installed at many airports, where only the thermal range they have diagnosed, and it was delivered. Because we say that all those startups, those who were working into some field, and they have delivered in this COVID challenge. So this is also a delivery in COVID challenge. They have delivered. So the screening was required at a time. Many machines are being sourced and procured by the government and installed. So Niramai's machine was also a good solution at that time. In fact, our vaccine is also reappropriation of the previous existing technologies. So they did a good thing. I really appreciate their work. That's why I have kept here, and Uni4 I kept here with me in my discussions.
Yes.
Thank you, ma'am.
Thank you so much.
Adding that.
Lata, shall we start the valedictory function?
Ma'am.
Sir,
you principal sir join agil. Start madla ma'am.
Sir ಕೇಳಮ್ಮ. ಸರ್ ಇದ್ದಾರೆ ಬಟ್
ಕಾಲ್ ಮಾಡಿ ಕೇಳಲ್ಲ ಮ್ಯಾಮ್.
ಕೇಳಮ್ಮ.
ಸೇರ್ತಾ ಇದ್ದೀನಿ, ಒಂದ್ ನಿಮಿಷ ಸೇರ್ತಾ ಇದ್ದೀನಿ.
ನೋ ಪ್ರಾಬ್ಲಮ್, ನೋ ಪ್ರಾಬ್ಲಮ್ಸ್.
ಓಕೆ, ಅದನ್ನ ಮಾಡೋಣ. ಮಾಡೋಣ ಈ ವೀಕ್ ನಲ್ಲಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್, ಥ್ಯಾಂಕ್ ಯು, ಥ್ಯಾಂಕ್ ಯು. ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಅಮ್ಮ.
Good evening all. Myself Dr. Lata BT, Associate Professor, Department of CSE, UEC. On behalf of Department of Computer Science and Engineering, UEC, I would like to take this opportunity to welcome you all to this valedictory function of 16th International Conference on Information Processing, ICInPro 2021. It's my great pleasure and privilege to welcome our distinguished guest, Dr. Venugopal KR sir, Honorable Vice Chancellor, Bangalore University, Bangalore, and Publication Chair of the conference. Welcome you, sir.
Namaskar. Good afternoon to all of you.
Deeply honored to welcome Dr. P. Deepa Shanai, Finance Chair of the conference, Professor and Dean Faculty of Engineering, UVC. Welcome you, ma'am.
Thank you, thank you.
Gracious welcome to Dr. H.N. Ramesh sir, Principal, UVC. Heartily welcome to Dr. Dilip Kumar SM sir, Professor and Chairperson, Department of Computer Science and Engineering, UVC. Welcome you, sir. Heartily welcome to Dr. Triveni J, Professor and Officer on Special Duty, UVC, and Finance Chair of the conference. Welcome you, ma'am.
Thank you, Lata. Thank you.
Delighted to welcome Dr. Arunlata JS, Professor and Tutorial Chair of the conference. Welcome you, ma'am.
Thank you, Lata.
Warm welcome to Dr. Shaila K, Professor at VKIT and Tutorial Chair of the conference. Welcome you, ma'am.
Thank you. Thank you.
I extend my warm welcome to faculty, research scholars, students, and participants. Welcome you all. We have been listening to eminent keynote speakers deliberating on Python, data extraction, role of AI and ML and data science, machine and deep learning applications, computing with Julia, unwinding Alexa, 6G and its enablers, information processing, and presentations by authors since from 2 days, which has given us new perspective to adopt for the research. Now I request few of the delegates to share their views about the conference. May I request Ebin Deni Raj from IIT Kottam to share the views about the conference.
Yeah, good evening. Hope I'm audible.
Yes, you are.
Yeah. So I haven't attended all of the session, but mostly like 60% whatever I've attended, what I've noted is like you guys have maintained the highest quality in whatever you do. So I'm really looking forward for the future conferences as well. And it was really a great experience for these 3 days. Thank you.
Thank you, Ebin Deni Raj. May I request Dharavat Ramesh from IIT Dhanabad to share the views. Dharavat Ramesh.
ಇಲ್ಲ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕರಿ.
First see whether they are joined.
ಜಾಯಿನ್ ಆಗ್ತೀವಿ, ಎಲ್ಲ ಫೋನ್ ಮಾಡಿ ಹೇಳಿದ್ದಾರೆ. Okay.
What is the name?
Dharavat Ramesh from IIT Dhanapur.
Ramesh.
ಎಲ್ಲ ಬೆಸ್ಟ್
Ramesh
ಪೇಪರ್ಸ್
ji
ಅವ್ರನ್ನ ಕರೆದಿದ್ದಾರೆ. ಬೆಸ್ಟ್ ಪೇಪರ್ಸ್ ಅವ್ರನ್ನ ಕರೆದಿದ್ದಾರೆ ಸರ್.
Yeah, he's not there.
May I request Sandeep S. Patil from KBC North, Maharashtra University to share the views.
Yes, hope I'm audible to madam. Am I audible to you?
Yeah.
Yes,
Audible,
madam.
audible. You are
Yes,
audible.
thank you. Respected dignitaries, Professor, respected dignitaries, Honorable Vice Chancellor, sir, all the dignitaries. It is a fantastic conference. Thanks so much for all of your thoughtful and effective organization. I am always impressed with the commitment and efficiency of those who planned this conference. I really enjoyed all the keynote and all the sessions at the conference. Thank you very much for giving me the opportunity to be a part of this conference. It was a pleasure to virtually attend this conference in well organizing mode. Thanks to all, and I am looking forward to next year this conference in offline mode. Thank you, sir. Thank you very much.
Thank you, sir. Thank you, Sandeep, sir. May I request Arun Kumar from Mysore to give the feedback? Arun Kumar from Mysore.
Yes, ma'am. Hope I'm audible and audible.
Yes, audible, sir.
And first, I would like to thank Vice Chancellor Venugopal sir, and also all the conference organizers, and as well as ensuring the conference is more delightful and not in a boring way, because always the face-to-face interaction gives a greater impression. But like though this year it's a virtual, it has been fantastic experience. It's not less than the physical presence of like doing a conference. So it has been great attending this conference, and also the keynote sessions are excellent. The top-notch technology is what being discussed as part of the keynote. That is something carefully chosen by the conference organizers. Big hats off to you all. And thanks for the opportunity in presenting the paper. And in fact, this is my first paper presentation. So big thanks to all. Look forward to participating in the upcoming sessions.
Thank you, Arun Kumar. May I request Shivani Inder to give the feedback? Shivani Inder.
Yes, ma'am. First of all, I would like to thank you all for giving me this opportunity for being part of this conference. I have attended a few sessions, and the sessions were really great and knowledgeable, though I belong to a field of business and management. But how these things can be extended towards machine learning and all that stuff, which we are, though I'm a beginner in machine learning and all that stuff, but listening to the views and how the stuff is taking change, how the transition is taking place from computer science, and how all those things are merging, the views, the variety of views, and about the research. I was actually thrilled by the knowledge that got poured into this conference. And it was a great experience connecting with the university, and the way organizers were very cordial and humble. And it was a great experience, and I really look forward for such few conferences in future as well. Thank you, ma'am. Thank you.
Thank you, Shivani. It's my honor to announce Best Presentation Award. Best Presentation Award goes to the paper titled Improving Storage Efficiency with Multicolor Deduplication and Achieving High Data Availability in Cloud, authored by Bhavya M, Prakash M, Dr. Triveni J, Dr. Venugopal KR. Now, may I request Dr. Venugopal KR, sir, our Honorable Vice Chancellor, Bangalore University, Bangalore, to address the virtual gathering.
Thank you, Lata, for introducing, but that is the best presentation award given only to Bhavya, not to the other people who are listening. So do not include my name and say, okay, that I presented the paper. The paper is for the best paper award is different from best presentation award. The best presentation award is to a person who is presenting the paper.
Yes.
Okay. So they should not have a feeling that I am the publication chair and therefore it is given.
No, Saulo, she just read out the authors.
Authored by sir.
Co-authors.
Co-authors, but the winner is Bhavya.
Thank you for inviting me to this valedictory address. It's really very, what you can say, a wonderful experience of conducting this first online conference from University Vishwesvaraya College of Engineering. The first day, when we started on Friday at 8 o'clock, was it 8 o'clock or 9 o'clock?
9, sir, 9. Yesterday it was 8.
It was 9 o'clock. And I could see about 100 people participating in the program. And some people switched on to YouTube. Now, if I had to assemble this 100 people at Fortal Capital at 9 o'clock, that was a Herculean task in all these 50 years. I used to make a number of phone calls and make those people guests and all those people who had to present and the students who had to come. Hundreds of telephone calls and tension, accompanied with tension, to run the program at 9 o'clock. Now, in this year, this version of the program, we have seen that everybody logged on and we could see 70 to 80 people exactly at 9 o'clock, and we are able to start, and we are waiting for about 2 to 3 minutes for others to join. This is a very pleasant experience of conducting the conference on online mode as well as an offline mode, an hybrid mode, I can say. The keynote addresses were the best part of this conference. Every keynote speaker brought in his rich experience with him and shared his knowledge to this august audience. I can say without any doubt that this is one of the leading conferences in the country. And I was very happy that we could conduct some programs offline, especially the inaugural program, the Best Paper Award. The Best Paper Award was read out, or were identified during the inauguration. And we were able to conduct the cultural program. It was a wonderful evening, the first day, where I could see more than 200 people participating in the cultural festival during the occasion of the first day of this program. It is needless to say that the number of people who have put in constant effort over the last 2 months in order to see that this program is well stitched and well versed and well conducted. All those people, especially the faculty members, the IEEE volunteers, and the faculty of computer science and engineering, along with its research scholars, have contributed to the success of this program. I would like to mention a few things during this valedictory address. One, you know that bringing out the proceeding in time is very difficult. Though we had asked all the authors to format the paper in a particular style, many of the authors were not able to do it properly. And so when the authors do not format the paper properly, the burden will lie with the editor. And I, being the first editor, and dying positive of time, definitely we were not able to get the proceedings before the conference. And therefore we had to get the conference proceedings as a draft copy. Of course, many people were involved in bringing these proceedings. And I would like to particularly thank the team which worked for bringing out the proceedings. I think Rupa had put in a lot of effort in bringing out the proceedings, at least the draft version. So thank you, Rupa and her team. Second, it's not just enough to thank one person. There were many faculty who were involved in bringing and formatting the papers, and including the research scholars who had formatted individual papers and they have sent it. Then we were able to stitch it in time and try to bring a copy as though the Springer were like as published. I congratulate all those people, research scholars, faculty, along with Rupa, for getting out this proceedings code. Every proceedings will have some drawback, and this is only a draft, so you don't have to get worried. When you work, there will be mistakes. When you don't work, there is only one mistake. That is, you don't work. And when you work, there will be hundreds of mistakes when you work. That's why you must be able to bear even the criticism. Criticism should be taken in a positive aspect. When somebody criticizes, you must tell yes, that I have to do better. That's what I have done in my life. Every time I learn from my students. I learn from the mistakes which I committed earlier. I try to reform, I try to change, I try to become better, and then you will slowly move from one to a next step, and next step, and next step. But nevertheless, you will be able to reach that goal only in the end. And it is not possible for anybody to be a novice or a person who just starts to master this. Even after 40 years of my research work, I can close my eyes and tell you that still I have not been able to get a dream paper of mine, that is IEEE transaction paper. So every time I tell my students, okay, try to publish an IEEE transaction paper. I try, they will go to some extent, again I fall back. But that does not frustrate me. That does not tell, okay, I should give up. I still keep trying. And that is the way you should move forward. We have come to the 16th version of this conference. And you can imagine, it is a very long journey. I still remember how I and Deepa Shenoy were sitting in a press during the 2005 Intelligent System Conference, which was sponsored by University of Melbourne by P. Palaniswamy. They gave 6 lakhs of rupees and said that we should conduct the conference. Then I thought, okay, this is a big opportunity for us. Then, it was so difficult. The odd page numbers had come on the even page, and the even page numbers had come on the odd page. So again, we had to reprint. Then we see, okay, when we are trying to bind the book, when the proceedings we have forgotten the spine. Again, we had to rebind the book. And Professor Deepa Shenoy was there working overnight for that particular proceedings. Of course, we have all now become little older and we have got extinguished. It is the juniors who have to learn from the past experience. You have to take from the experience of whatever we have failed and whatever we could not do. If you just see that first conference book, which is right in front of me, I feel, okay, see what is the state of that conference book when I see the proceedings that was brought out by Rupa in the 16th version. It is really much better than the version which I produced and printed, published on behalf of IEEE, New York. And this is printed on behalf of Springer Verlag, Germany. And this version is much better than the version which we printed in 2005. But that is an experience. That is a journey. So the journey is long, hard, and definitely this experience, you have to take it to a next level. You have to move from the past mistakes and then try to become better and better. So in this journey, there are a number of people, every year in some version or the other version, somebody will be deeply involved. For example, for some years, Professor Shaila was bringing out the proceedings. And I remember still that it was so difficult for me to, bring out these proceedings in the earlier years. Then we outsourced it to Madras, a person typesetting in Madras. For 2011 and 12, we were able to outsource to a person in Madras, and we used to send that proceedings to Germany to print. And people, the editorial board of Germany, Springer Verlag said, we have already done all the work. And so we were able to get the proceedings even before the conference started. And on the day of the conference, we used to release that, proceedings. But things have changed. Now everybody wants to be, we were getting copies for each and every author there. But things have changed. We are now with online versions. And we can only get a few copies as hard copies. And of course, everybody can get printed on demand. If you place an order to Springer Verlag, they'll print the online copy and then they'll send a hard copy to you. But that does not serve any purpose because we should not waste paper and that we should not erase forest areas. Things have changed, the technology has changed. A drone can plant 1 million saplings now in a day. So we don't require people to take everyday one program and put it in the newspaper. Or we have to have that magic drone which will plant 1 million saplings in a forest area or in a desert area. So technology has changed. What we have seen from the first lecture, Sajjal K. Das, that first keynote address, we have seen that smart sensors or smart sensors to smart cities to smart living. And that's what we are trying to move towards. Now, when you see this conference journey, that's what we are trying to do. It was very difficult to bring out the proceedings at that time. Now it is very easy to get the proceedings in this version. And the journey is not just a rosy path. It is a path of thorns and as well as roses. So when you try to pluck a rose, you'll also be stung by or you'll also get hurt by the thorns. So whenever you try to conduct a program, conduct a conference like this, there will be many criticisms. For example, previous day, when I came and saw the arrangements in the seminar hall, it took more than 1 hour for me to organize again the placing of the chairs, how the screen should be brought down when Anand Atriya is going to present himself from New York, and how that screen should come and go back again. It might be a very small thing, but every small thing affects the final outcome of the conference. So we have to fine tune. We have to look into the details. And the next day when I came, we saw that, we should, every steps on the staircase, it should be plastered with that yellow-green so that it looks nice. And then we said, flowers should be kept on the every steps and that looked nice. So when you see the photographs and when you put it on the YouTube, everybody is trying to say, oh, what is this? Is this the staircase of UBC? Then everybody, when they are looking through YouTube for the cultural program, they were saying, is it the same UBC or is it the same quadrangle where this performance is being conducted? Everybody was thrilled to see the program that it is like a 5-star hotel. And for this 5-star hotel, we used to spend about 20 lakhs every year to run this type of conference. And now we have come to 6 lakhs for this conference. That means our expenses are cut down. And I should thank each and every research scholar in giving some contribution, finance to run this program. Please do not think that, okay, we are spending, why should we spend some money, so much money, or why you should part with this money. It is just that all the research scholars which are under one umbrella, you come forward, you see, you enjoy, and that is life. And that is life. Finally, when you are a good research scholar, when you write a paper, or when you present a paper, when you get a best paper award, all this has an impact on our life. When I have said that I am an author of 1,000 papers, 72 books, 33 patents, it gives me some type of pleasure. When I see all the students, I felt so happy during the cultural program that I sat and watched in the platform where we built around the trees to sit down and enjoy the tuning. It was a beautiful sight. When I see all those students, still my PhD students, growing, occupying different positions, becoming head of the department, even becoming syndicate members, you get that happiness, because what is purpose of life? Finally, purpose of life is to see that you keep others happy. See, purpose of life is you see that society progresses. Your purpose of life is you see that the next generation will be better placed than us. The purpose of this life is to help others, to serve others, and to be at the service. And that service to people is service to God. And that is what we are trying to achieve. That is how we have to achieve moksha. Moksha is a very imaginary world for us, most of us. Moksha is what you try to attain when you are living. Moksha is that when you are trying to experience when you are living, because we do not know whether we attain that moksha when we are dead. But when you are living, that moksha is happiness. That moksha is service. The moksha is serving people and society. Now, how should I thank all the people who are involved? First, I would like to thank Professor Deepa Shenoy, who is the senior most now to lead this conference. Thank you, Professor Deepa Shenoy, for working for such a long time, over long hours, and trying to contact all the people. And next, I have to thank the other Professor Champa, Professor Dilip, Professor Chandramesh, the next round of leaders. And then I have to thank Triveni, Aruna, Manjula, and all the next round of teachers. And then I have to thank all my PhD students, each and every PhD student. What for what? You might ask for what? Some people for working, some people for attending, some people for not working, some people for being absent, some people for participating. It is because everybody will have their work. If there was time, they would have come and attended. If there is no time, they have attended virtually, because most of the students said that some students said that they will not be able to attend physically. They were attending all these presentations as well as keynote lectures from their home. And so it was a very pleasant sight that participation actually increased in this hybrid version of the conference. So I thank each and every PhD student of mine. I've given 30 PhDs so far. And the last 2 PhDs were given just before this conference started. That is Santosh Pathak, and my last student is Rupa. These 2 students have done wonderfully well. And they have been, particularly Rupa has been conducting my classes for the last 5 years. And you see that she used to share my classes, and that is a very good thing. Now I am actually hunting for new students. And that's why today I've already sent a message that I'm going to start taking classes for the PhD student, how to write a research paper, how to conduct, how to do research, and how to patent. This will be my topic. And this I always cherish, and I relish to take such type of classes, especially for PhD students. Then Kiran is another person who will get a maximum number of scoldings from me. Whoever is in front of me has to be scolded. That scold, it is a curse or a blessing. But perhaps finally it will be a blessing. Initially it will look very awkward. It will be unpleasant. But when everything comes out well, when everybody tells that, okay, the program has come out well, I think he will have the last laugh at me. See, this man cursed and all the people are praising me. And that is how it goes on for each and every student. And finally, I should thank Lata, then the other, Venkatesh, Sanyama Bunjal, Champa, then Tanuja, then what the others, the Dharmendra Chauhan.
Sir, maximum work was done by Pushpa, sir.
Correct. See, that's why we always forget the people who have who are behind the scenes. When I started this conference, I said who should be drafted for this conference. Then it was the first name was Pushpa, whom I have proposed. When I don't, so the closest people will be forgotten very easily because they'll be so close that you will not be able to see them because they'll be just beside us, so it will be too close. Then what we'll see will be in front of us, and there will be a lot more people who will be seen by us. And thank you, Pushpa, for conducting this program so well. And not only this, Pushpa has done well in every program that she has been assigned. Every program she has been done well. So if you forget the name also, it is there in the proceedings. And the proceedings will keep a record. I might forget telling her name or bringing out her name, remembering her contribution, but time alone will tell. Like that, you don't have to worry about getting mentioned. I am feeling everybody, nobody need to be mentioned. Finally, what you do, how you work, it will be recognized and people will realize. So many people, they say that I don't work and I don't really worry much about it. But ultimately, someday, when your biodata, when your profile is read out, Pushpa, you will know that you have worked for this conference very well. And we can bring up one more thing is that Professor Kiran, take care of the certificate. There is a spelling mistake. Remove that mistake off and print as University of Vishweshwara College of Engineering. And it should be redistributed to all these organizers whom we had already given them and presented them on the first day.
Yes, sir. Yes, sir.
Then, to the authors, somebody said that this is my first paper presentation. And so it is, the authors have to be careful. They have to move from one to another. You must know how to write a paper, how to present a paper, how to organize a paper, because once you are a teacher, I think you are a teacher and also after completing your PhD, you have to guide students. So you have to learn only through the hard way. There is no cross-cut method or a crossroad, or you must follow the path of hard work, and you have to follow the path of what I can say is by experience and by actually getting involved with dedication and commitment. So have I mentioned or I left out any names?
Sir, I want to continue, sir, if you give me 2 minutes.
Yeah, have I left out any names?
Yes, sir, many names. So I since I know what each one has done, I want to talk for 2 minutes, sir, if you allow me, or after your speech.
Okay, so this is another aspect. I should thank Professor L.M. Patnaik, Professor Rajkumar Bhuya, Professor R.L. Kashyap, Professor S.S. Iyengar, and also the people who were present on the first day, Professor Kumar Naik, Professor Rupa Rai, and Shatabdani Ganesh, and Anandatriya. Those people, the best alumni awards, we have to give it as a distinguished alumni award from next year, because most of them want a title, and so it is better that we say distinguished alumni award at the conference. So these people have also done well, and keynote addresses were very good and very useful and meaningful, and all those IEEE volunteers and the staff members of UBC and Bangalore University. So I thank all this organization, individuals, and also groups who have contributed in the success of this conference. Thank you, one and all.
Thank you, sir, for your inspiring.
Lata, yeah. Thank you so much, sir. I would like to continue for 2 more minutes. Just to extend what sir has told. Thank you so much, sir, for the opportunity given. Since sir was extremely busy in his work, we never used to disturb sir about the conference, and we started the work of conference somewhere in November last year, and we first tried with ACM, which could not come through, and we went to Springer and they agreed. And initially we formed a very small team consisting of me, Pushpa, then Shrikantaya, Satish, and 2 UG students. And I would like to mention the name of Deepak Gerard, who helped us a lot in developing the entire program committee team. But in between, he had to leave because of health issues and some personal and professional issues. He helped us a lot. And thank you so much, Deepak, in your absence. Then, along with Pushpa and Shrikantaya was a great advisor, because already he had brought up, he was working for Springer conference in his college. And every now and then we used to ask him for the procedures, how to proceed, how to apply, how to go about, what to write, what not to write. And he helped us to get Springer through. Then Sunil Kumar was the interface between Springer and UVC. He managed all the mails between Springer and UVC, correctly answering the mails, and so that it could come through. Thank you, Sunil Kumar. And Pushpa, I would say all the work, sitting and doing the work, he did it. So Deepak is here. Deepak Gerard, can you switch on the video?
I request all the participants to switch on the video so that at least that will be colorful. We can take a group photograph.
Yeah, Deepak.
Yes, ma'am, I'm here, ma'am.
Yeah, today we are seeing Deepak. He really increased the standard of this conference by bringing very good people in the program committee, in the reviewer list. He gave us 200 names. He wrote to each and every person, and he could get them into the team of ICInPro 2021. Thank you so much, Deepak. In between, he had to leave due to various reasons, but it is okay. Initially, you have helped us a lot. Shrikantaya, thank you for being the support to connect to Springer. Okay. Then Pushpa, I would say whatever was required, I used to tell Pushpa, sending the mails, then review process, getting the papers, and then talking to reviewer authors. Everything was done by Pushpa, and the quality of review process was improved by Triveni. Triveni came in at the right time, and Triveni, switch on the video.
Thank you, ma'am.
So because of her, we could do the review process properly. We started early. We started the review process somewhere in April 8th to be exact. We started very early, and systematically we could do review process because of Triveni. Thank you so much,
Thank
Triveni.
you so much. Thank you.
We initially took 2 UG students to develop our website. They were very enthusiastic in the beginning, but you know that they have their own commitments and aspirations. They could not carry for a long time. So then we thought that we have to hire an expert and who is good in developing the website. So we contacted our Vision UVC member, that is Satish, and he did everything for the conference, so that the conference website is looking professional and good only because of Satish. So every update he is to do it nicely, and we included him in our small group of ICInPro 2021. Next, I would like to thank Pratibhavani, because she is very enthusiastic, though youngest in the department. Whatever work we give, she will do without any problem. So we asked her about the tutorial speakers, and the entire tutorial was managed by her. We never interfered, and she got very good tutorial speakers and from a company, and the student gave a feedback that it was very, very informative and very good, and they learned a lot from the tutorials. Let me thank Shaila and Aruna for managing the keynote speakers, though I'm very selfish to say that out of 7 keynote speakers, 6 were decided by me. and one was brought by Shaila. But managing them, contacting them, then mails, and then managing the keynote sessions, everything was done by these two along with my PhD students. And I'm very happy that all the keynote speeches were very good and very informative, and students can do a lot by these speeches. Kiran.
Thank you, ma'am.
Yeah, thank you, Shaila. Thank you, Aruna.
Thank you,
I would
ma'am.
say that, I would say that Kiran came only at the end. I called him at the end to manage the show, like managing the wedding. We always say that conducting a conference is nothing but conducting a wedding. A lot of arrangements goes on for 1 year or 10 months, searching a girl, searching a boy, seeing the family, engagement, then shopping and other things. But what people see is the wedding, how well the wedding is was conducted, how was the food, how is the boy, how is the girl, the flower arrangements, then the wedding hall and other things. So this job of collecting the contributions from the students, I started giving it to Kiran, and he managed it very well along with his students. And the entire arrangements from the seminar hall, flower, food, and then mementos, everything was done by Kiran along with the students. Thank you so much, Kiran, and I'm happy that you are my student and I can depend on you both. That's what I was telling him, both during the good times and low times and bad times. So we are there for each other during every time. So
thank you,
thank
ma'am.
you
Thank
so
you very much, ma'am. Thank you, ma'am.
And ICIPro students, they did wonderful job for the last 15 days. We called them only for the last 15 days. Everything was done by IEEE volunteers without asking for anything. They never used to ask for the food also. Lunch, dinner, nothing they asked, but they work continuously. I don't know whether Prithvi and his team is here. Thank you, Prithvi and his team. And PhD students, we are very happy that 77 PhD students are there and around 20 are on the campus. They did a wonderful job managing the stage, managing the sessions, keynote speeches, then paper presentation sessions. Everything was managed by our PhD students. A big thanks to you. I think I have covered only the key people who Rupa also, because of her PhD Viva, she could not work in the beginning. We were telling her, Rupa, prepare the proceedings, start working, but we could never disturb her because her PhD Viva was on 7th October, right, Rupa? 7th October, Thursday. We usually conduct a PhD Viva on Thursdays only. So because of that, she took the work little late, but efficiently she completed and brought out the proceedings. Thank you so much, Rupa, and all the best to you in your future career and future endeavors. Do well in life. Okay, be professional, do the work sincerely. And all these things we could do because of our teacher, Venugopal K.R. sir. Thank you so much, sir. Though you are busy, we knew that you are watching us. And everything we did, keeping you in mind, not to reduce the standards to your expectations and your level, we try to work silently. Thank you so much for the opportunity given. I have done 3 conferences. I think same person doing same type of work, then it becomes monotonous. I feel that the next batch, Triveni should take over and take the lead. And if we conduct the next conference, Triveni and her team should work, and we should be just the observers and the advisors. That's what I feel now. 17 teachers are there, and I am retiring in 1.5 years. I should not take the lead. That's what I feel. And thank you very much, sir, for giving me the opportunity. And I hope that this conference was a success. And Sunil still has the responsibility of bringing the proceedings from the Springer. He is working on it and it has to come. Sunil, you still have the job. And Kiran, you have to give all the accounts. We have to settle the accounts and we have some more works to go. Thank you so much, sir. Thank you so much for giving me the opportunity to talk and express my gratitude. Thank you so much, one and all.
Thank you. Thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Thank you, madam.
Our VC sir and PDS ma'am already thanked all one. I request Rupa to extend that. I request Rupa to present vote of thanks.
Good evening. It gives me an immense pleasure to propose a vote of thanks on this occasion. I, Rupa MS, on behalf of organizing the 16th International Conference.
Rupa, Iru, one nimisha sir keltidare innenu illu anta. Sir, this time we had divided the review process amongst a group of teachers like Tanuja, Lata one group, Anuja one group, Triveni and one group, me and Kiran one group. So all of them, they managed that review process very nicely. So we had divided the paper under various headings like networks, IoT, computational intelligence, data science and all. And every group took care of the review of the papers under their stream. So review process became a little systematic and professional. Thank you very much for conducting or managing the review process.
Okay, Rupa.
I sincerely thank Dr. L.M. Patnaik sir, Adjunct Professor, INSA Senior Scientist, NIAS and General Chair of ICInPro 2021 for gracing this occasion in his absence. Thank you, sir. I wish to express my gratitude to our Honorable Vice Chancellor of Bangalore University and Publication Chair, ICInPro 2021, Dr. Venugopal KR sir, for providing his encouragement and constant support to conduct this program. Sir, we will ever remain grateful to you and we thank you for being with us today. I would like to thank
and that is true.
Thank Professor H.N. Ramesh, Principal UVC, for his constant and moral support to conduct this conference. Thank you, sir. I would like to thank Dr. P. Deepa Shenoy, Syndicate Member, Bangalore University, Dean.
Nilsama, idu ಏನು ಗೊತ್ತಾ ಸರ್, ಡಾಕ್ಟರ್ ವೇಣುಗೋಪಾಲ್ KR ಸರ್ VC ಅಂದ್ಬಿಟ್ರೆ ಆಗೋಯ್ತು, ಬಟ್ ನನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡುವಾಗ ಸಿಂಡಿಕೇಟ್, ಡೀನು, ಪ್ರೊಫೆಸರ್ ಎಲ್ಲ ಬರ್ಬೇಕು, ಯಾಕಂದ್ರೆ ಐ ಆಮ್ ನಾಟ್ ನೋನ್. ಅದಕ್ಕೆ
Finance Chair, ICInPro 2021, for her
everybody
continuous
has
support
to
to conduct
acquire
this
something and
conference.
then they have to come down.
I extend my thanks to
Everybody has to reach the top and they have to come down.
Yes, sir. Okay, Marupa, continue. Sorry for disturbance. Okay.
I extend my thanks to Dr. S.M. Dilip Kumar sir, Professor and Chairperson, Department of CSE, UVCE, for his cooperation to conduct this conference. Thank you, sir. I extend my thanks to Dr. K.V. Raja, Dr. Triveni J, Dr. Arunalata, Dr. Shaila, Dr. Shrikantaya, Dr. Kiran K, Dr. Pratibhavani, and Dr. Sunil Kumar for their encouragement to conduct this conference. Thank you all. I thank all the plenary speakers, the tutorial speakers, session chairs, reviewers, media persons, and the delegates for their enthusiastic participation in this conference. Our heartfelt thanks to major sponsors, Bangalore University, Computing Professionals Charitable Trust, CPCT, and the publishers Prinjava Lab in the series Communications in Computer and Information Science for the support to conduct this event. Last but not the least, I thank all the volunteers for their involvement and willingness they have expressed to take on the completion of the task beyond their comfort zone. Hoping this conference benefits you all greatly and helps you to carry forward this knowledge wherever you go. All the best. Thank you, one and all.
Okay, everybody switch on the video for a photograph. Everybody switch on the video. Irshad Khan, Ramanna, Sangeeta Yu, Kavya Shri, Narshimalo. Switch on Made. All of you switch on the video for a photograph. Yamuna Raju, Aarti, Geeta Mara, Shashi Kiran,
Sanjay Majumdar, sir, even you also, you can switch on the
Rahul,
video, sir.
Vandana, Sanjay Nagendra, Suprita, Lata BT.
ಸರ್ ನಂದು ಸ್ವಿಚ್ ಆನ್ ಇದೆ ಸರ್, 2 ಇದೆ, ಅದ್ರಲ್ಲಿ 1 ಸ್ವಿಚ್ ಆನ್ ಇದೆ ಸರ್.
Okay. Anu Matthews, Veena, Subhash Kamble. Ella switch on ಮಾಡಿ. All of you switch on the video for a photograph. So photograph ಯಾರು ತಗೊಳ್ತಾ ಇರೋದು? ಸುನಿಲ್ ಫೋಟೋಗ್ರಾಫ್ ತಗೊಂಡ್ಬಿಡಿ.
ಓಕೆ
ಎಲ್ಲ ಇದು ಎವ್ರಿಬಡಿ ಸ್ವಿಚ್ ಆನ್. ಅರುಣ್ಲತಾ ಇನ್ನು ಮಲ್ಕೊಂಡಿದ್ಯಮ್ಮ? ಇರ್ಷದ್, ಆಯ್ತಾ? ಕ್ಲಿಕ್ ಆಯ್ತಾ?
1 second ಸರ್, ಆಗ್ತಾ ಇದೆ.
ಎಪ್ಪತ್ತೆರಡು ಜನ ಇದ್ದಾರೆ. ಮೂರು ಬರುತ್ತೆ. ಕ್ಲಿಕ್ 3 ಕ್ಲಿಕ್ ನಲ್ಲಿ ಬಂದು
ಹಂಗ ಇದಾಗ ಬರಲ್ಲ, ಡಿಫ್ರೆಂಟ್ ಫ್ರೇಮ್ಸ್. ಬಟ್
ಒಂದು ಫ್ರೇಮ್ ನಲ್ಲಿ 25 ಆಗುತ್ತೆ ಅಲ್ವಾ?
25 ಆದ್ರೂ ನೀವು ಸ್ವಾಪ್ ಮಾಡಿದಾಗ ಅದೇ ನೆಕ್ಸ್ಟ್ 25 ಬರಲ್ಲ ಸರ್ ಸಮಟೈಮ್ಸ್.
ಅದು ಎಲ್ಲರೂ ವಿಡಿಯೋ ಆನ್ ಮಾಡಿದ್ರೆ ಅದೇ ಬರುತ್ತೆ. ವಿಡಿಯೋ ಆನ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ then it will get switched on to different locations.
ಆಯ್ತಪ್ಪ, ಎಲ್ಲಾರ್ನು ಆಲ್ 72 ಕವರ್ಡ್.
ನೋಡಿ ವ್ಯಾಲಿಡೇಟರಿ ಫಂಕ್ಷನ್ ಯಾವ ತರ ಆಗ್ತಾ ಇದೆ ಈಗ.
ಎಸ್ ಸರ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
I would like to thank our keynote address speaker, Sanjeev Kumar Majumdar, Manager, National Research Development Corporation, Delhi, for his informative session. Thank you, sir.
Thank you so much, sir. ಅಲ್ಲ, ಅವ್ರು ಕೊಟ್ಟರು. Initially there were some technical problems, but it was very informative.
Okay, so we'll end the program.
Yes, sir. Thank you so much.
Thank you all for attending this conference and valedictory function, which is part of this conference. Thank you all.